Hi, today we're looking at AQA Functional Skills Maths Level 1. This is the November 2021 paper, and we're going to start with the non-calculator section. Question 1. Circle the number that is 7 less than minus 10. Right, well, let's draw a number line to start with. So with the number line, it's always good to have a 0 on it. But we're starting with minus 10 because it's saying less than minus 10. So this is our starting point. And it's 7 less than minus 10, so it's going to be going to the left. So we're going to be going minus 11, minus 12, minus 13, minus 14, minus 15, minus 16, minus 17. So that's 7 down we've gone. So there's our answer. Question 2. Work out 12 squared. So 12 squared, that means 12, not times 2, but times itself. So 12 times 12. Okay, and I'm going to do it as a column. So we're going to say 2 times 2 is 4, and 2 times 1, or 1 times 2, is 2. Now we're moving on to the tens, so we can put a 0 in the units column. We're saying 1 times 2 is 2, and 1 times 1 is 1. Now we need to add these together. So 4 plus 0 is 4, 2 plus 2 is 4, 1 plus nothing is 1. So we've got 144, which is this number there. Question 3. Work out 36 minus 5 times 7. So this is relying on you knowing your order of operations and that multiply comes before minus. Okay, so we're going to do the 5 times 7 first. Well, 5 sevens, we've got 7, 14, 21, 28, 35. So we can replace that with the 35. Now we've still got the 36 minus the 35. Just because we've done this first doesn't mean we swap it and move it. We've worked it out first, but it still stays in the same position. Okay, so we've now got 36 minus 35. We can work it out, but hopefully you could just count up from 35 and say one more is going to make 36. But if we do it with the column, you'll see 6 minus 5 is 1, 3 minus 3 is 0. So our answer is just 1. Question 4. Complete the table to show equivalent fractions, decimals, and percentages. Right. Well, if we want to make a fraction, I'm going to start with the percentage. And I'm going to say, well, 75% just means 75 out of 100. And I'm going to leave it like that. I could simplify it. You could make it 3/4 if you want, but they haven't said to simplify it, so we can just leave it as 75 over 100. Okay. Which should we go? We'll start with the decimal to make the percentage. To get from a decimal to the percentage, we need to multiply it by 100. So that means that we're moving the decimal place 2 places over. Okay. So if the decimal point moving it 2 places over. So if the decimal point is there, that means we're going to have 70%. And now we're trying to make a decimal. Well, we multiplied by 100 to go from a decimal to a percentage. If we want to go from a percentage to a decimal, we're going to go the other way. So we're dividing by 100. So if you imagine a decimal point is here, we're going to move it 1, 2 places. So we're going to have 0.2. Question 5. Use 5 times 16 equals 80 to work out 50 times 16. Okay, so what you'll see is that we've got the same digits. We've got 5 here, we've got 5 here, we've got 1 and 6 and 1 and 6. What's different is that we've got a 0 here and a 0 point on that one. So we've got to think how that's going to change things. And really all that's going to do is that's either going to put a decimal point in somewhere or it's going to move our zeros. So if we think about, well, 5 times 16 is 80. Well, if we made it 50 times 16, well, all we're doing by adding a 0, it's like we're multiplying by 10. So all we'd do is that would just add a 0 on the end. So we've sort of done this bit, this 50 bit. Now, multiplying by 0.16, well, that is like moving the decimal point 2 places there. So we're just going to do the same to the answer. Move that there. So what that's telling us is that 50 times 0.16 is going to be equal to 8. Question 6. Party planning. Hanifa is planning a party. 6a. Hanifa hires a hall for the party. The hall is a rectangle and measures 12 metres by 9 metres. Okay, well they've told us that, so I'm just going to do a quick sketch. There's my rectangle, 12 metres by 9 metres. Okay. Here's a list of what she wants in the hall. We've got a DJ table, 1 metre by 2 metre rectangle. So again, I'm just going to draw a quick sketch of that, 2 metres by 1 metre. A refreshments table, 1 metre by 3 metre rectangle. So that's going to be 3 metres there, 1 metre that way. And a dance floor, which is 5 metres by 5 metres squared. So this one's a square. And I'm not trying to do these to scale, just so I can picture what these are going to look like. There must be a space of at least 1 metre round each table. On the scale diagram below, draw and label a possible plan for the hall. And you can see we've got this square, the scale 1 square represents a 1 metre by 1 metre square. So let's see what we've got. This is what we've got to use. Okay, and on this picture, we've got to fit our DJ table, our refreshments table, and our dance floor. Now, if we look back at these and look at the measurements, the dance floor is the biggest one. So I'm going to put that one on first, because usually the biggest one can be most awkward. So let's fit that on. So 5 metres squared. So it's going to be 5 squares. But remember, it did tell us there must be a space of at least 1 metre round each table. So I can't start right in the corner. I'm going to start with my dance floor here. And I'm going to go 1, 2, 3, 4, 5 metres that way. And 1, 2, 3, 4, 5 metres that way. Make this into a square. And we can write on this dance floor. Okay, what I'm going to do actually, I'm going to just write on here, this is 12 metres, this is 9 metres. So we can put 5 metres by 5 metres, okay, just to make it all clear. Right, then the next biggest thing we've got is a refreshments table, which is 1 metre by 3 metres. Again, we need 1 metre all the way around it, so I'm going to do it over in this corner. I'm going to have it 1 metre going that way and 3 metres going up. So we can write refreshment, okay? And we can put 3 metres and 1 metre. Now the last thing we've got is the DJ table, and I think I want the DJ table to be quite close to the dance floor, and it's 1 metre by 2 metres, so let's put it, have 1 metre coming down and 2 metres across. And there we have it. Not bad for 4 marks. Yeah, just make sure you use your ruler. Do it in pencil. Well, you should do all of these drawings in pencil anyway. If you do make a mistake, you can just correct them. And sometimes that's the way to do it. Don't be too scared to start. Plot something, or you could even do a sketch to start with, a bit like the way I did with my tables, drawing them out on the dance floor. And then you can picture them and just feel a bit more confident when you're drawing them on the actual picture. So, question 6b. Here are the amounts Hanifa spends on the party. We've got DJ hire is £433, food and drink £278, hall hire is £11.50 per hour. That's important. Dance floor hire is £10 per square metre. And it says the hall is hired for 4 hours. Show that altogether Hanifa spends £1,007. Okay, so we need to add up all of the costs. Well, the DJ hire is just that amount. Food and drink is that amount. The hall hire, we're going to need to multiply this. So it was 4 hours. So what we want, I'll do it over here, we want 1150 times 4. Okay, so I'm actually going to ignore the decimal point to start with. I'll just do 4 times 5. Well, that's 5, 10, 15, 20. 4 times 1, or 1 times 4 is 4, plus 2 is 6. And another 1 times 4 is 4. Now we had one decimal place here, so we can put the decimal point back in. So 46.0, or because it's pounds and pence, we should have 2 decimal places, so £46. Okay, so I'm going to put 46 here. In fact, I'll put these in so that then we can add them all up afterwards. The dance floor hire, £10 per square metre. Well, how many square metres have we got? Well, you might remember that the dance floor was a square which was 5 metres by 5 metres. So the area is going to be 5 times 5. 5, 10, 15, 20, 25. So it's going to be 25 metres squared. But it's £10 for each of those. So if we're multiplying it by 10, well, we're just going to put a 0 on the end. So it's going to be £250. So I'll put that here, and we can add these all up. So 3 plus 8 is 11, plus 6 is 17, and 0 is still 17. 3 plus 7 is 10, plus 4 is 14, plus 5 is 19, plus 1 is 20. 4 plus 2 is 6, plus 2 is 8, plus 2 is 10. So we've got a total there of £1,007, which agrees with this. Job done. C. Hanifa put £960 in a bank account 1 year ago. She gets £5 simple interest each year. Is there enough in the account to pay the £1,007? You must show you're working. Well, what this is asking us to do is work out how much interest she's going to get, add it onto the original amount, and compare it to the £1,007. So we want 5%. Well, I'm going to start off by saying, well, there's not a nice easy way, not without a calculator, to go straight for 5%. You could do 5 divided by 100 times 960, but that sounds a little bit messy. So what I'm going to say is, well, I'm going to start off with 10% of £960. And if I want 10%, I just take off the 0. So that's £96. Well, 5%, well, 5 is half of 10. So if we want 5 instead of 10%, well, we want half of £96. So half of 10%, half of 96. So we want 96 divided by 2. We'll do that with the bus stop method. How many times does 2 go into 9? 2, 4, 6, 8, 10 would be too many, so we stop at 8, which was 4 times. We've got 1 left over, because 2 4s are 8. We've got 9, so from 8 to 9 it's 1. And how many 2s in 16? 2, 4, 6, 8, 10, 12, 14, 16. We've got 8. So we've got £48. So she started off with £960. Then she gets another £48. So if we add these together, 0 plus 8 is 8, 6 plus 4 is 10, 1 plus 9 is 10. So we've got £1,008, which is more than £1,007. So yes, there is enough. And that's the end of the non-calculator section. So now we've got the calculator section. Question 1. Circle 32,089 written in digits. Let's think about this. 32,000, so 32,089. Right, now we haven't got any hundreds, so we need to put a 0 in there. And the way you can spot that something's missing is I knew that there had to be a comma there because of the thousands, and I know that we've always got to have 3 digits to the right of the comma. So that should help you to remember that something's missing there. So 32089, that's the one we want. Okay, question 2. A fair ordinary dice is rolled once. So by fair, they just mean there's the same chance of getting any of the numbers on the dice. On the line, mark with an X the probability that the dice lands on an even number. Well, if you've got a dice or a die, you can get 1, 2, 3, 4, 5 or 6. Now the even numbers are 2, 4 and 6. Or in other words, 1, 2, 3 out of a total of 6 chances. So we can write that as 3 out of 6. Now we've got 1, 2, 3, 4, 5, 6 here, so 3 out of 6 is going to be in the middle. Or in other words, it's a half. Question 3. Write these numbers in order, starting with the smallest. Okay, well, the negative numbers are smaller than the positive numbers, so we've got, these are my negative ones. And we want to know which is the most negative, because that's going to be the smallest. Well, the biggest digit with the negative numbers is the -8. Then we've got -5. Then -2. Then the -1. Now 0 is going to go in next. Now we've got our positive numbers, and all we've got left is 2 and 3. So we're just putting those smallest to largest. Question 4. Measure the size of angle X. So for this one, we need our protractor. I've got one here. So with this, we've got to find the crosshairs there and put them on the angle where the 2 lines meet. Now I then need one of these lines. I can either do it that way and measure the angle from left to right, or I can line it up with this line here, and then I'm using the numbers on the inside because I need to be starting from 0 each time and go round on that little blue semicircle. So as I've got it here now, I'm going to do it that way. So there we're going to read round, and you can just see you might need to move it to see the lines up there, and it's coming through. Well, if you look on the outside numbers, it says 20 degrees, but 20 is only if you're counting from the left. We want this angle, so we're using the inside numbers, which is actually 160 degrees. You should also remember that with your angles, an acute angle would be less than 90 degrees. So less than a right angle. This is clearly bigger than a right angle, so we know it's got to be more than 90 degrees. So we'd know that if we wrote 20, we could tell straight away that wouldn't be correct. Question 5. Draw all the lines of symmetry on this shape. So line of symmetry, a line that goes straight through the object, splits it into two equal shapes, but we in a mirror image. Okay, so it's much easier to show than to try and describe it. Hopefully you can see if we draw a line straight through the middle, if we put a mirror there, that picture on the left would be perfectly reflected on the right. Now we've got one down the middle. What about if we do a horizontal one as well? So if we put a line through there, the top would be perfectly mirrored in the bottom. Horizontal and vertical are usually the easier ones to spot, but what about, is there anywhere else we can reflect this shape? Well, if we turn it, sometimes it makes it easier. See, looking at it now, you can say, well, what about if we go through that way? That, so we've got the top matches up with the bottom, and then similarly, we can do one straight through there, so left and right. So we should have 4 lines of symmetry in total there. But don't be scared to turn the paper to try and look at these shapes in a different way. Question 6. Work out which is smaller, 15% of 180 or 20% of 120. You must show your working. Well, this one is going to be 15 out of 100. Of always means times. So we can just take our calculator. 15 divided by 100 times 180. We've got 27. With this one, it's 20%. So 20 divided by 100. Again, of means times. 120. So 20 divided by 100 times 120. Gives us 24. Okay. Which is smaller? Well, 24 is less than 27, so 20% of 120 is smaller. Question 7. Here are 5 numbers. 37, 58, 19, 12 and 58. Work out the range. Well, the range is the biggest minus the smallest. Which is the biggest number? 37, 58 is bigger. Yeah, we've got 2 58s, but that doesn't matter. It's still the biggest number. And what's the smallest? 12 looks like the smallest to me. So we want 58 minus 12. Get our calculator back. We've got 46. Eight, charity shop. Melissa works in a charity shop. People donate clothing to the shop. Some of the clothing is sold in the shop and some is sold for recycling. 8a. Melissa keeps a record of the clothing sold in the shop 1 month. So we've got item of clothing, so shirt, coat, jumper and dress, and we've got a tally of how many of each were sold. Melissa says more than a quarter of the items sold were shirts. Is Melissa correct? You must show your working. Right, well, we want to know how many, we've got the tally, we want to turn this into actual numbers. Well, with the tally chart, you always do 1, 2, 3, so you do a line for each one you're counting, and then on your 5th one, you cross them through. So this is 5, 5, 5, so 5, 10, 15, shirts. Coats, we've got 5, 6, 7. Jumpers, we've got 5, 10, 15, 20, 1, 2, 3. Dresses, we've got 5, 10, 11. So more than a quarter of the items sold were shirts. Well, how many were sold altogether? So let's add these up. So we've got 15 plus 7 plus 23 plus 11 is 56. Well, what's a quarter of them? Well, a quarter of 56 would be, well, we've got 56, so we can multiply it by a quarter, or 1 divided by 4, which gives us 14. More than a quarter of the items sold were shirts. Well, 15 is more than 14, which was a quarter of them. So is Melissa correct? Yes, she is. (8b). When Melissa sells clothing for recycling, she receives a basic amount of £1.20 per 500 grams of clothing. 10% extra if she sells a batch with more than 100 kilograms of clothing. So there's two things. I'm going to put a dash there. They're two separate things. Melissa sells a batch with 143.5 kilograms of clothing for recycling. How much does she receive? Well, 143.5 is more than 100, so she is going to get this extra. Okay, but before we do the extra bit, basic amount of £1.20 per 500 grams. So we want to know how many 500 grams of clothing has she got? Well, the batch that we're given is in kilograms at the moment, but I know that we've got 1,000 grams in 1 kilogram. So if we multiply the 143.5 times 1,000, that's going to give me the total weight in grams. 143.5 times 1,000. So we've got 143,500 grams. Now we can work out how many 500 grams go into this. So we're going to say 143,500 divided by 500. And we get 287. Now we get £1.20 for each of these, so we want to multiply this by £1.20. So 287 times 1.2, £1.20, gives us £344.4. Because it's money, we need 2 decimal places. So it's going to be £344.40. Now she gets 10% extra if she sells a batch with more than 100 kilograms of clothing. We've already worked out she's going to get that extra. So 10% is going to be 10 over 100 times £344.40. So times 10 over 100. So that's an extra £34.44. So we can add that on to the original amount, which gives us a total of £378.84. 8C. Melissa sells bottles of shampoo in the charity shop. Melissa fills the bottles from a container that holds 12 litres. How many bottles can Melissa fill from the container? And we can see that one shampoo bottle has got 400 millilitres, or holds 400 millilitres. So as before we had grams and kilograms, it's much easier if you can just get one unit of measurement. So here we've got millilitres and litres. Well, let's turn them all into just millilitres. We could turn them just into litres, but if we did that, we're going to end up with decimals, which is messy. So it's usually better to go to the smaller measurement so you can avoid having decimals. So I know we've got 1,000 millilitres in 1 litre. So if we do 12 times 1,000, well, you can use your calculator, but I'm just going to put my 3 zeros on the end. So I've got 12,000 millilitres. Right, we want to know how many 400 millilitres we can get out of that, or how many of these bottles we can fill up. So that's the same as saying 12,000 millilitres divided by 400 millilitres. Okay. We can do it with a calculator, but we could cancel a 0 with a 0, 0 with a 0. So now you've got 120 divided by 4. Or you could say, well, 12 divided by 4, 4, 8, 12 is 3, and then put the 0 on. Okay, so a quick way of checking it, but look, let's do it with the calculator. So 12,000 divided by 400, and we still get 30. So either way you want to do it is absolutely fine, but it helps if you can do this sort of thing quickly. It's a good way to do a check and make sure you've not got one too many or too few zeros. Question 9. Bakery. Brandon works in a bakery. 9a. Brandon uses scone mix to make scones. He needs 360 grams of scone mix to make 8 scones. Brandon wants to make 40 scones, and he has 200 grams of scone mix. Again, I'm going to mark these as like bullet points because it's two things. He wants to make 40 scones. He has 200 grams of scone mix. How much more scone mix does he need? Right, well, the simplest way to do this is say, well, how much does he need for 1 scone? So we're going to do 360 divided by 8. So that's 45 grams for 1 scone. Okay, but we want 40 scones, so we want 40 lots of 45 grams. So 45 times 40, we get 1,800 grams. But he already has 200 grams of scone mix, so we can take that off because we don't need that. We've already got it. So 1,800 minus 200 is going to leave us with 1,600 grams that we need. And if we look at the answer box down here, they've got it in grams, so we leave it as it is. If they did have the units as kilograms, well then we'd need to divide that by 1,000 to get 1.6 kilograms, but they've got it as grams, so we just need to leave it as it is. (9b). Brandon is making a birthday cake in a T shape. Here is a plan view of the cake. So plan view means looking straight down onto it. And we've got measurements for some, not all of the sides, but most of them. Brandon has enough icing for an area of 200 centimetres squared. Does he have enough icing for the top of the cake? You must show your working. So we want to know what is the area, or the top area of this cake. And then we can compare it to 200 centimetres. So what we're going to do is we're going to split this into a big rectangle at the top and then a square down here. Well, the area of a rectangle is the length times the width. Well, what's the length of this shape? Well, it's going to be 8 centimetres. Well, if you think of it like this, it's going to be this length plus this length plus this length. These two are going to be the same, so it's 8 plus 6 plus another 8. So with the calculator, 8 plus 6 plus 8 gives us 22 centimetres. So our length is 22. What's our width? Well, that's this way. Is 7. 22 times 7 times 7 is 154 and that's centimetres squared because that's the area. Now for this, it's a square because we can see all the sides are the same length. So the area of this is just going to be 6 times 6, which is 36 centimetres squared. Again, you can use your calculator if you want. So if we want the total area, we need to add those two together. So the 154 plus the 36 to give us 190 centimetres squared. Brandon has enough icing for an area of 200 centimetres squared. Well, 190 is less than 200, so yes, he does have enough. (9C). Let me line it up. Brandon wants to buy a box large enough to hold 16 kilograms of flour. He uses this formula. The volume of the container in centimetres cubed is the weight of the flour in kilograms times 2,400. He sees this cuboid box for sale. Can this box hold 16 kilograms of flour? Right, so we've got two calculations we need to do, really. The first one is to work out what is the volume of this cuboid. And the volume is the length times the width times the height. In this case, we've got a length of 35, a width of 30, and a height of 40. So 35 times 30 times 40 gives us 42,000 centimetres cubed. Okay, now we can use this formula as well. So the weight of the flour is 16, and we want to multiply that by 2,400. Which gives us 38,400 centimetres cubed. So this is the size that we need. This is the size we've actually got. So 42,000, what we've got is bigger than what we need. So yes, it can hold it. You could do this slightly differently. What you could do is you could divide the 42,000 by the 2,400 to find out how much weight you'd need, and then compare that to the 16. But I think this is probably a more straightforward way of doing it. But either way would be fine. You should get the same answer whichever way you do it. Question 10. Working from home. Spencer works from home for a call centre. 10A. Spencer works 3 days a week from 7:30 a.m. until 12 noon each day. He is paid £151.47 per week. Is this more than £11 per hour? You must show you're working. Well, let's work it out. Well, how many days, or how many hours is he doing each day to start with? Well, 7:30 until 12. So let's go up in hours first of all. So we've got 8:30, 9:30, 10:30, 11:30. We don't want to go up to 12:30 because that's after the time. So we've got 4 hours to 11:30. And then from 11:30 to 12 noon, well, that's 30 minutes. Or you can think of that as 4.5 or 4.5 hours. Now he's doing that for 3 days a week. So we want 3 lots of 4.5 or 4.5, which is 13.5 hours. So that's the total number of hours he's working. Well, let's work out if it was, no, what should we do? Yeah, let's do it this way. I'll show you another way afterwards. Let's multiply that by £11. It's 30.5 times 11. So if he was getting £11 an hour, he would be getting £148.50. But actually he's getting paid more than that, so he must be getting more than £11. So we can say yes. What we can do instead, or just like an alternative, so we'll do an or, we know that he's getting £151.47 per week. We know that he's working for 13.5 hours. So if we divide the 151.47 by 13.5, 151.47 divided by 13.5, this will give us his hourly rate, which is £11.22 per hour, which is more than £11. So that's just an alternative. I think this is probably nicer, because then you're doing a direct comparison. It's a bit easier to see. (10b). Spencer can claim an amount for each page he prints for work. 1 month, he claimed £2.76 and he printed 138 pages. The next month, he printed 97 pages. At the same rate, how much can Spencer claim? Right, well, let's work out how much he claimed per page. So £2.76. Let's think of this in terms of pence. So that's going to be 276 pence, or 276p. You can multiply it by 100. Remember, there's 100p in each pound, so 276p. So if that's the total amount, if we divide it by the 138 pages, this is going to be how much it is per page. And it gives us exactly 2p. And I put per page. If he's printing 97 pages, well, we want 97 times 2, which gives us 194p. And if we want to make it pound, we're going to put the decimal place in 2 positions over, so it's going to be £1.94. We can put that down here. 10c. Spencer makes phone calls for work. He has a target that on average his calls should last less than 5 minutes. Here are the times that his calls lasted one day. So 7 minutes, 3 minutes, 2 minutes, 11 minutes, and so on. Okay, these were each of his calls. So we had in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 calls. Did Spencer hit his target that day? You must show you're working. Right, so on average, so what they're talking about when I say average, we need the mean. This is our average. And the mean is the total divided by how many, or the frequency. Okay, well, we've already worked out the frequency, the number of calls, so we're going to be dividing it by 12. What we want to know is what is the total number of minutes spent talking. So it's going to be 7 plus 3 plus 2 plus 11 plus 7 plus 5 plus 6 plus 5 plus 9 plus 1 plus 6 plus 7. We've got a total of 69. Now, if you're in the exam, I'd probably do this calculation more than once, or do it very carefully, because it's so easy to make a mistake when you're typing lots of numbers into your calculator. Well, 69 divided by 12 gives us an answer of 5.75. Did he hit his target? Well, 5.75 is more than 5, so no, he didn't hit his target. He needed them to be less than 5. Question 11, school leavers. Students leave a school at the end of year 11. 11A. The pie chart shows what students did when they left the school last year. So we've got this section here. Went to school with a sixth form. This section here went to college, and a small section went on an apprenticeship. Move this up. 90 students went to a school with a sixth form. So I can write 90 in there. How many more students went to college than started an apprenticeship? Okay. Well, let's have a look at the angles here. So we know that we've got 180 degrees for this bit, and we got 90 of them. So how many degrees for each of these people? So in other words, if we do 180 divided by 90, you might be able to see what the answer is going to be on this. And we get 2. So that's 2 degrees per person. Okay. So that means if we want to work out how many went to college, we can say, well, 160 divided by 2 is going to tell me how many people. So that's 80 people. Or students. Let's call them students. That's what they're calling them, per student. And the same with this 20%. If 2% is one student, well, how many students are going to be 20%? So we're saying 20 divided by 2. That's going to be 10 students. And the actual question was how many more students went to college and studied an apprenticeship? Well, went to college was 80, an apprenticeship was 10, so we want 80 minus 10. You can use your calculator, or you can just take the 1 off the 8 and say we've got 70 students. (11B). On the last day, the students will have a 40-minute lunch, then a 15-minute registration, then a 35-minute assembly. The students will leave school at 1:50 p.m. What is the latest time lunch should start? So let's work backwards. Right. You could add this all up and then take it off. Shall we do? What I'm going to do is actually go backwards. So we're going to start at 1:50 p.m. So this is the leaving time. Imagine that they're leaving at the end of all of this. So working backwards, first of all, we want to take off 35 minutes. Okay, so 50 minus 35 is going to take us back to 1:15 p.m. Then we need to take off a 15-minute registration. So we're going to take off, and I shouldn't put it as point, I'm going to put 2 dots because this is time. So we've got 60 minutes in an hour, not 100. So taking the 15 off of that, that's going to bring it back to 1 p.m. Then we need to subtract 40 minutes for lunch. This is the bit where you could make a mistake here. Well, 40 minutes, we're not taking 40 off of 100 because, as I said, there's only 60 minutes in an hour. So we want 60 minus 40 is going to make it 20. And because we're going backwards, we've got nothing to take off, but it's like we're carrying one over. So what's the hour before 1 o'clock? Well, it's actually 12 o'clock. And it's still going to be 12:20. It's still going to be PM because it's after midday. And finally, 11C. Javed is going to be an apprentice bricklayer. He needs to buy 2 jackets. He sees these offers in 2 shops. Shop A. Jackets, usual price £24. Special offer, 1/3 off the usual price. Shop B. Jackets, usual price £21.80. Special offer, buy one, get second half price. He wants to pay the lowest price possible. Which of these shops should Javed choose? You must show you're working. Right, we're third off the usual price. Let's start with Shop A. So we want 1/3 of £24. We'll work out the discount and then take it off the 24. So now you might have seen this thing before, where if we do 1/3 of 24, we're going to get a bit of a rounding issue, which isn't too difficult. We can round it up to 8. But if we do the whole number first, so 24 times 1/3, it's tidier for us. So the discount is £8. So if we take that off of the original price, 24 minus 8 means that they're £16 each. Right, but he needs 2 of these jackets. So we want 16 times 2, which is £32. Now, what about Shop B? Special offer, buy one, get second, half price. Okay, well, how much is the half price one? So it's going to be half of 21.80. So 1 divided by 2, or you could type in 0.5 times 21.80 is £10.90. So the first jacket costs £21.80, the second one costs £10.90. If we add those together, we get £32.70, because it's money, we need 2 decimal places. Well, 32 is less than £32.70, so Shop A is cheaper. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to my channel, have your notifications on so you find out when I add more videos. And if you did like this, remember the best way to do it, you can either go on the homepage of my YouTube channel and see the different videos there grouped together by exam board and by level, or you can click on playlists and have a look there. Again, they're grouped together, easy for you to find whichever papers you want. Thanks for watching. See you again soon.